In today's video, let us discuss about the symmetric wave function, antisymmetric wave function, which is known as spin symmetry and spin antisymmetry, and Paulis exclusion principle. Now, as we know that symmetric wave function means those wave function which do not change their sign if you are exchanging the particles, while the antisymmetric wave function, they will be changing their sign on exchange of particles. So if you are denoting the wave function by psi, so for symmetric, psi 1 2 will be equal to psi 2 1. So example is bosons, and they will show you the spin 0 1 2. Whereas for antisymmetric example will be fermions, and it will be denoted by psi 1 2 will be equal to psi 2 1, but we are taking minus sign. So this is antisymmetric wave function, and such behavior is shown by fermions, and they are having spin like half 3 by 2. Now let us talk about the Paulis exclusion principle. This you have studied in your earlier classes also. That is a statement. What it says that no two electrons can have all the four set of quantum numbers same. That is principle azimuthal magnetic and spin quantum number. It cannot be same. So for explaining that, let us consider a system of two non-interacting identical particles, and let us say particle 1 and particle 2. Particle 1 is in the quantum state A, so the eigenstate wave function, you will be denoting it with psi A, and the particle 2, it is in the quantum state B, and you will be denoting it by psi B. So this is psi A1, psi B2. Total wave function psi 1 2, that will be psi A1, psi B2, and if we exchange it 2 1, if I am making, this will be psi A2 and B1. So the linear combination of two wave functions, what they are giving us, they are giving us a symmetric wave function. There is no change in the sign. Let us denote the wave function psi s by 1 by root 2, psi A1 B2 and A2 B1, where this is required, as we have done earlier also, to normalize the wave function. So this is for the symmetric. For anti-symmetric, you will say psi 1 2, it will be shown by psi minus 2 1. That means A1 B2, that will be minus A2 B1. So psi A you are denoting by 1 by root 2, psi A1 B2 minus psi A2 B1. Now if we consider A and B, they are same. That is two identical particles, they are having same set of quantum number. Then if they are same, then psi will be 0. That is the probability of two anti-symmetric identical particle is 0, and or you can say no two interacting fermions, they cannot be same. That is as per the Paulis exclusion principle, because if A is equal to B, we will see what we will get. So if A is equal to B, so instead of B I am writing A. Here also instead of B I am writing A. So what, this will get cancelled and you will get 0. So in that case you will say A cannot be equal to B. So that is what a Paulis exclusion principle is saying, that two identical particles, they cannot have same set of quantum numbers. So A cannot be equal to B. So this was what was explained by Paulis.